In this video we're going to look at finding the volume and surface area of a cylinder, sphere and a cone, and by default then we look at finding maybe a hemisphere or maybe half a sphere or things like that. Okay, first thing I have here is a formula. These formula can be gotten in the logbook on page 10, I think. The ones in red are straight, can be taken straight out of the logbook. The ones in green can't. They're not in the logbook, but with a little bit of thinking you can actually find them pretty easily or derive them yourself. Right, first thing I'm going to do is I'm going to take the cylinder, and this cylinder has a radius of 5 and a height of 6, and the best thing for me to do is just do the question for you, okay, to do a little bit of revision. Right, first of all I'm going to get the volume. So the very first thing I would do as to find the volume of a sphere, or sorry, a cylinder, is I would write down the formula. So the formula is volume equals pi r squared h, and all I do is fill in what I know. So I don't know the volume, so leave it as v. I know what pi is, 3.14. Okay, in this I'll take pi as 3.14, I won't leave it as pi. The radius then is 5 squared, and the height is 6. You'll type this into your calculator, you'll get the answer. Simple as that. Okay. Next one then is the curved surface area. So imagine this can is a can of beans. The top bit and the bottom bit are flat, so that's not curved. So we're looking for the area of all the outside curved bit. Okay, so all of this really, the whole way around. There's a formula for it. That's curved surface area equals 2 pi r h. Again, fill in what we know. So curved surface area equals 2 multiplied by pi, which is 3.14, multiplied by r, which is 5, multiplied by h, which is 6. Type all that into your calculator, you get your answer. Right, if they ask for the total surface area, well, that's not in our logbooks, but think, the total surface area is the curved surface area. So total surface area equals, well, it's definitely the curved surface area, so we can get that formula down, 2 pi r h. Plus, now think, what shape is the top? It's a circle. And the formula for a circle is pi r squared. And what shape is the bottom? It's another circle, so plus pi r squared. And if I was to simplify that formula, it would be 2 pi r h plus 2 pi r squared. And all I do is take that formula, fill in what I know. So I know what pi is, I know what the radius is, I know what the height is, throw it in the calculator, and off we go. Okay. They might give us a question like this. They might say, here's our cylinder, drawn badly, and the volume of it is 150 centimeters cubed, and the radius is 3, and the height we don't know. Find the height. Okay. All we'll do, write down our formula, volume equals pi r squared h, put in what we know. So this time we know the volume, we know pi, we know the radius, we don't know h. Okay. And all we'll do is simplify and use our powers of algebra to find out what h is. Okay, and I'm not going to do that for you because you should know how to find one unknown in an equation. Okay, so there's your one unknown. We know all the rest. So all it is multiplying and taking away from both sides until we get h. Okay. Okay. Next we look at the spheres. So again, exact same as the cylinders. There's a formula here for spheres. It's in your logbooks. If you're given the radius and you want to find the volume, just take the volume formula, find it, just throw in what the radius is. If you want to find the curved surface area, get the radius, put it in. If you have the curved surface area and you want to find the radius, put in the curved surface area, use your algebra to find the radius. Okay, I'll do one of those in a second for you. And likewise, if you're given the volume and you want to find the radius, you'll put in the volume and you'll work back to find the radius. Okay, I'll do that for you now. So let's say we had a cylinder, 90 pi centimeters cubed, and we want to find the radius. That's volume equals 4/3 multiplied by pi multiplied by radius cubed, and we put in what we know. So we know that it's 90 pi equals 4/3 multiplied by pi multiplied by the radius cubed. The secret in this is if we're given our volume in pi, then leave this as pi also, because now we can cancel both. Or another way of saying it, we can divide both sides by pi. So we're left with 90 equals 4/3 multiplied by the radius cubed, divide by 4/3, divide by 4/3, and you're going to get 120 equals the radius cubed, and then just get the cube root of this, and you get radius, get the cube root of 120, and you get whatever that is, and that's your radius. Okay. Last one then. Let's say we are given a hemisphere, which is half a sphere, and we're asked to find the volume of it. That's no problem at all. Take your radius, put it into this formula, okay, the volume formula, and when you get your answer, divided by 2. That's common enough sense. However, if we're asked to find, the curved surface area, again the same. Put your radius into the curved surface area and divide your answer by 2. However, if we're asked to find the total surface area, well, what we have to do is we get the curved surface area first, which is this. Okay, so how we do that is, again, use the curved surface area formula, divide by 2. But remember, it's total surface area, so there's a circle on top. So we're going to have to get the curved surface area of the overall sphere divided by 2 to get the hemisphere, and then we're going to have to add a pi r squared for the circle on top. Okay? Right, last one then. Volume of a cone, 1/3 pi r squared h, works exactly the same as the cylinders, so just write down your formula, put in what you know, it'll help you find what you don't know. Curved surface area then is pi r L. Now L is the slant height, and this is it. Sometimes we won't be given L, okay? Or sometimes we'll be given L and we'll be asked to find the height. Or sometimes we'll be given L and the height, we'll be asked to find the radius. Okay? But how do we do that? Simple really, we can use Pythagoras' theorem. We do have a cone here, but if you turn a cone a certain way, just lay it on a table and tilt your head a certain way, it'll actually look like a triangle. And it's a right angle triangle. So if we have, let's say, this side and this side, we can find this side, which is L, which is the slant height, okay, using Pythagoras' theorem. I'm not going to go through Pythagoras' theorem, you should know it already. So again, if you want the curved surface area, you might need to use Pythagoras' theorem to find L or R maybe. If you have it, throw it into the formula and you can find the curved surface area. Sometimes they might give you the curved surface area and you might have to find L. That's no problem, use the formula again, throw in what you know, use your powers of algebra to find your unknown. The last one then is this, if they want the total surface area. Total surface area will be the curved surface area, all of this, but it'll also be the area of the circle below. Hence why we have the formula for total surface, for curved surface area, and we add on a pi r squared, because that's the area of a circle underneath. And again, that's not in our logbooks, but common sense would get you there. Okay, I'm not going to do that for you, because they're pretty straightforward. A bit of practice should be, and it should be no problem to anyone. So here's 4 questions for you. Find the area, find the volume, the curved surface area, and the total surface area for each of these questions. So if you pause this and do it through the best you can, okay? And just to let you know, I'm not giving you the length of L, so you're going to have to use Pythagoras' theorem to find it.